Hello everyone, my name is Sheena and this is my homework 4 video for INF 503. So in this video, I'll be walking through both the result and logic behind my implementation of the uh, Needleman winch and blast algorithm. So I'll also give a detailed explanation of my monsoon CPP code. So first I'll start with my write-up. So I'll start with the part 1, problem 1. So in problem 1, I use a real genome fragments from the subject data set extracted into 30 two character and mouse and compared them against the query dataset using a full Needleman Wunsch alignment. So the matches found here were um, 5940 hits for 10K, for 100K it's 58765, for 1 million it's 613912 hits. But this time was huge over 118,000 second for 1 million and roughly 251 days if applied to the whole genome. So in 1B, where I use random sequences, the number of matches dropped as expected and only about 61K for 1M and MERS, but the runtime actually increased to um, 43,000 for 43 lakh 9,000 seconds, and that's because Needleman's Wunsch still does full alignment when even when there's no chance of a match. So let's go to the problem B here. For problem B, which is blast, implemented a blast using a seed and extended strategy. I use 11 more word seed to pre-filtered matches before applying the Needleman Wunsch extension. So in 2A with real genome segments, it's were high up to 53, 5,38,200. This was much better, just 81,902 seconds for 1 million. So in 2B, I can say that with random segments, matches were lower, around 59,000. Um, um, and runtime was still far better than the NW 96,832 seconds. So Blast provided a very good trade-off between speed and accuracy, especially for large-scale searches. So part two, like I'll explain my this is all about the theory part that I did it, and this is the comparison. If I go to the monsoon code that I have written over here, and I have created bl.cpp and nw.cpp file, which I'll explain you. For what I did is I created this two file. Both the classes store the query data set using 2D array structure to hold all and merge. So I'll go with the class NW first. So this is header file and this is CPP file. What all I have declared in the header file, I'll explain it to in CPP file. So in NW class, I have used the constructor load and store and merge from the query, and the destructor freeze allocated the memory, and NW aligned the perform Needleman Wunsch alignment between two sequences, and here I have used the um, score to score all those details, and the best match to iterates over all the query and merge and return the one with the best score. And what else? This run function, it's walkthrough. I initialize um file over here, and I loop it through this by using if statement, and I've used the while loop over here to get the details, and I compute the score for match mismatch and take the max of here. I have computed the score and for match and mismatch and take the max of diagonal up or left direction at each step. And finally, the best score is the value in the bottom right of the matrix. So yeah, this is how I have implemented the class and the function here. If I go to the next class, which is queries BL class, it uses the same structure but adds a seed filtering mechanism. So if I go with the this function one by one, so here um, um, the one function is character seed from the subject and matter. For each query, it's checking if seeds matches any position. If a seed match it found, only then call new align to extend and verify alignment. This helps avoid full NW alignment unless a new seed gives a strong a signal. So I can say the difference between part A and part B. In both NW and BLAST, part A use real genome segments, more biological similarity, more hits, and part B use random inputs, fewer matches. So, but NW did full alignment regardless of match quality, and so the time went up even for random data. And blast filter aggressively, so it saved time and was more efficient for both real and random data sets. So the bugs and fixes that I did here is, initially only I compared the 11 characters as seed. Later I fixed it to extract all overlapping seed from both query and subject and merge. Also I had incorrect initialization of first row and column in NW alignment fixed, and I've fixed that, which matched the score significantly. Coming to the optimization that I did to speed up the blast, I added early termination in the explanation phase. Once a match score reached the max, I broke the loop and returned immediately. So thanks for watching my video. This is how I implemented. Yeah.